Okay, looks like we're live here. Hello, everyone. I'm Dr. Paoletti, and I'm going to be doing the first lecture today. I'm going to switch my screen over here for a second. I've got Professor Darden on the line, and he can say hi. Just one second, I got to change my source.
How's it going, folks? It's good to see you. It's ready to do this.
Okay, a very short intro from Professor Darden. You're going to be seeing him tomorrow. We're generally going to be swapping every 2 days, so I'm going to be doing most of the Monday, Tuesday. He'll be doing most of the Thursday or Wednesday, Thursday. And so we've got other staff with us this semester. We've got 7 IAs and possibly going to add a few more if we can get them. We've also got, you'll see, this is the last thing on my to-do list to get ready for the new semester is turn on the Potato Bot, is a sort of an AI tool that monitors Piazza. It'll do things like if you haven't added your unique name in parentheses, it'll remind you. It'll also give you helpful hints like, hey, it looks like your post has already been answered before. Have you tried reading like @X and @Y? And you'll look at them and you'll go, wow, that @X was just what I needed. And @Y had nothing to do with what I was asking about. But, you know, the potatoes powers of AR are limited. So our weekly schedule, and thank you someone for pointing out that I forgot to update the time in this. I updated everything else. So I uploaded a new set of slides when I noticed that. So we've got Monday through Thursday, 10:30 to 12, and obviously if you found us live, you know where we are. And the link is on the Canvas schedule of topics. Even if we forget to make it public after lecture, it's still accessible via the link. We just have to make the live streams unlisted because the second, not the first, but the second time we did a live stream that was public, we had trolls in our chat channel and it was a pain to get rid of them and they kept coming back and took a little time away from the students. So that's why they're unlisted to begin with. The labs, if you look at it, says Google Calendar, but if you look at where it says lab schedule on the left, we've got the lab schedule there, who's going to be covering each section. It's got links, at least to some of them. I know I told them to finish by the end of today, getting their Zoom links populated for the labs. You do not have to go to the lab you signed up for, but we would like you to go to the same lab every week because that will make it consistent who you're working with, etc. Important dates. So now there's a crash course posted on YouTube. Next slide has a bunch of links. And we've got the midterm coming up in like 3 weeks and a few days, 3 weeks and a day. And then a month after that, the final. Spring goes fast, and I understand this. I took a spring course when I was an undergrad. We were on a quarter system. We had a 10-week course compressed into 5 weeks. It was a 5-credit EE analog control systems. So it normally had lecture 5 days a week. In the summer, we had lecture twice a day, 5 days a week, 2 labs a week. So I know what it's like for you doing these summer classes accelerated. So we try to make this as doable as possible, yet still as close as possible to the experience you would get if you were taking it during a normal semester. So we used to do one long session. If you want to look at it, the link is there. I would suggest skipping that one. And then what we've got is what we recorded last semester, some new ones in pieces. That, since we didn't do it in person, we recorded them in pieces. So you should watch one of the first 3. Pick your IDE, watch the video about it, and then do both of the last 2. And so those will help you with getting started and using Xcode and Visual Studio. Even if you've been using Xcode or Visual Studio for a class or 2 years, what doesn't matter, watch the video. We're going to be doing things with your IDE in 281 that you have not done before. And those videos will tell you how to do it. And then the last two videos are Project Zero, which is ungraded, but it's an introduction to, there's one or two topics in there that are going to be important to you, like what does it mean to resize or reserve a vector? That's going to be important for Project 1. You're going to want to resize your vectors in Project 1. And then the Makefiles tutorial is how to use our Makefile, which is linked online. Okay, syllabus, you can read that on Canvas, and we'll look at some of the things on Canvas in just a minute. So it's got a bunch of things we'll talk about that's from the syllabus and other places. Prerequisites, we do generally enforce the prerequisites, so you need to have 203 or Math 465, 565 generally beforehand. There are no grad students in this class. When we teach it in the winter, we have students in a class called 403 who are like on a totally separate grading scale from the undergrads, but they're not around in the spring. There's a preparedness self-survey on Canvas. It's under the quizzes tool. Canvas calls it quizzes. We can't change the name of it. So we use it for things. We don't have any quizzes per se, but we use the quiz tool for things like this preparedness survey, which is ungraded. If you haven't used Canvas quizzes before, that's a great place to look at it. Many of the labs will have a quiz component, which is really just multiple choice questions that you'll be able to read ahead of time. The quizzes for the labs, you'll be able to submit, I think, 2 or 3 times. And then we'll also use it for the exam. So getting practice with it before we get to the midterm is going to be useful. On collaboration, so everything for the projects and exams must be your own work. Anything, or it could be anything that we have given you. So anything that's in the slides, in the lecture, in the sample programs, in the labs, if it comes in the project spec, it's free to use. If you're retaking 281, I'm sorry to hear that, but the good news is you get to reuse your own code, anything that you did. For the labs, the only thing about retaking it is if you did the labs previously with someone else, don't just hand that code to people this semester, because that doesn't let them learn anything. So also don't show your project code. The project code is the most important. Labs, you can work with other people. But the project code, we do not want you showing it to other people. We don't want you posting it on Piazza. We don't want it in a public repository. On the autograder, when you submit your test files, we'll talk about what those are in a bit. The test files should be your own. And there are different projects every semester, but there is a pool of projects we draw from, and we draw from the same pool of projects. So you will have different projects from winter, but they will be the same topics, and they will be, some of them will be similar. So when in doubt, ask us. Come to office hours, ask on Piazza, is it okay to do this? Honor code, you can read the engineering honor code. There's a link on Canvas for it. We do take it seriously. We are turning in people from last semester. We hate doing it, but it happens. So hopefully it's not you. Is it okay to use external sources? Yes, for understanding. But don't look at code that you find online. Do not submit code you find online. We don't even have to find out that you found it online. We just have to find someone else who used the same source that you did, and we can catch both of you that way. So looking up things on how algorithms work, videos on how algorithms work, animations of how the data structures change, awesome. But once you look at code, it's hard to unsee that code. Getting help and contacting us, there's a general EECS 281 admin, which goes to all the instructors and a subset of the TAs who help monitor that address. We want you to use that rather than our personal emails because 1, there's more people monitoring it. 2, my personal email, sometimes I get 200 in a day, and I don't want to miss things important related to the class. So you can come to Proffice Hours. Our Proffice Hours, Professor Darden, I'll admit, was the one who coined that term, Professor Office Hours. We're going to be doing mostly a one-on-many, where we have a big meet, you join us, we'll answer questions. We'll also do one-on-ones for people who have to show us code or who have personal issues, medical issues, etc. If you want to handle those via email, that's fine. If you want to tell us, hey, I really need to talk to you in person, then come to Proffice Hours and tell us that you have a personal issue, and we'll have you make a one-on-one meet and join you there. Okay, other things to get help. CPP reference, cplus.com, pick one of those. Or look at both of them and figure out which one you like best. They both have pretty much the same content, just organized slightly differently. But I would get used to reading one of those and using it as a resource. Piazza, of course, we've got the Piazza link on Canvas. And like we said, don't post code publicly. Also, if you have like a follow-up and we answer it and you're happy with it, mark it as closed. Or often our staff will mark it as closed as soon as they answer you. And if it wasn't a sufficient answer, then post another follow-up, it'll reopen, and we'll deal with that one. But we tend to mark them as resolved as soon as we answer them. But if another student posts to your follow-up and answers it, then we'd like you to mark it as resolved. That'll save us a little bit of time on getting to answer more questions. So office hours, we like you to come prepared with specific questions. That's when, like, my code doesn't work is not a very specific question. I can get this small sample right, and if I change one character, I get it wrong. That's a really specific question that we can help more with. If you're coming with general conceptual questions, like, what does this part of the project spec mean? That's fine. If you want to come to the one-on-many meet and listen to other people's questions, that's great too. Lots of people will just listen to other people, and they'll raise their hand. I'll get to them in the one-on-many, and they'll say, "Oh, whoop! I forgot to put my hand down. Somebody else asked my question already." So the one-on-many meet, students think, "Oh, that one-on-many meet, that's useless. I just want to get in the queue, and I don't care if I'm waiting in the queue for 7 hours. I'm going to get my one-on-one help." Well, you probably could have gotten your question answered 6.8 hours ago in the one-on-many meet. So come to the one-on-many meet first. Where are we? Okay. The staff office hours, so the staff meaning our IAs and GSIs. I don't think we have any GSIs this summer. But the thing to remember is that if they have to close the queue and leave, it may be because they're taking a class this summer themselves. It may be they have something they've got to do. So if they have to leave and let people know they have to leave and close the queue, then please respect that. They've got lives of their own also. And then when office doors open, that one's outdated. We're not actually over in Bicester anymore. But anyway, so come to the Proffice Hours, come and ask us questions there, and we'll do personal ones if you need them. So, like I said, join the one-on-many meet. Join that before you get in the queue. If your code won't compile, then yeah, you probably need a one-on-many meet, because we need to look at your code to figure out what's preventing it from compiling. But if you're just saying, hey, I'm getting test cases A, B, and Q wrong, we can talk about that in front of everybody. I can say, hey, it looks like you're missing this, or maybe you're not dealing with the command line properly. So we can answer a lot of questions in the one-on-many. Okay, grading policy. So we've got 20% from the 10 labs, 40% from the 4 projects, 20% from each exam. So that's where the grade breakdown comes. Every lab is equally weighted. If we goof up slightly, like last semester, because of the Computing Cares survey, lab 2 was worth 23 points. We scaled every lab to be 20 points. So every lab is counted equally. So what guarantees that you will pass? So if you do all 3 of these things, you will pass. Even if you don't, according to the syllabus, get a C with your percentage, if you do all 3 of those, you will get a C. If you don't do all 3 of those, it doesn't guarantee that you don't pass. We look at those individually. And I saw someone asking about 2 or 3 grades. We still have to send out 281 grades. Our staff took a long time to grade the written problems. But we're at the stage now where we're looking really carefully at the people who they didn't quite meet those criteria, and we're making the decision, okay, did they do enough to show us that, yeah, they didn't meet the guaranteed passing, but we're still going to pass them. So if you're significantly off, though, we're not going to pass you. If you can't get close to 55% on projects, to be quite honest, I'm not going to turn you loose on upper level classes with groups that need to depend on you. So if you have a good overall total, but bad projects, we're not going to pass you. You need to, at least, if you get those minimums, you will pass. If you get close to them, we're going to look at it really carefully before making a decision. Okay, so the labs there are 10 lab assignments. You can work with other students, especially in COVID semesters. Before COVID, we'd let you work in pairs. Now we'll let you work with more than that if you want to. Just make sure that everybody's getting something out of it. If you're just saying, oh, yeah, my partner did the lab this week and I'll do the lab next week, when it comes time to the exam, you're going to understand one topic well and one topic poorly. So make sure that you're contributing to those things in the group. It'll help you prepare later. Now the labs, link to a form. Okay, we got rid of the form this semester. I'm sorry, I forgot to update this slide. We got rid of the form because it was just too much work. Just go to one of the lab sections, preferably the same one every week. Just pick one of them. It doesn't have to be the same one you signed up for, and then we'll have breakouts with other students to work on the labs and ask questions of the instructors, etc. Now, every lab has a written problem, and we used to do those in paper, which helped you get ready for paper exams. Now you submit them on Gradescope, which helps you get ready for our online exams where you submit your written coding problems via Gradescope. Now, the written problems are graded by effort. If you put some effort, you've got some code that looks like it's attempting the problem, we'll give you credit for it. Now, the exams, obviously, we're going to grade a little harder than that. But on the labs, the goal is to get you writing code all the time. Writing code makes you better at writing code. To get credit for the written problem, you must attend lab. However, we did something last semester. We're doing it this semester also. So if you miss 2 of the written problems on Gradescope, the first 2 written problems you miss, we'll give you credit for them. Or not even miss them. If you just put in you submitted it, but all there was a comment that said I didn't have time to do this, that still counts as a miss. So if you miss 2 of the labs, we'll give you credit for the first 2 that you miss. We don't want you to miss them. We want you to go to them. We want you to do them. We want you to get ready for the exams, but we understand with COVID and everything else in upheaval, you might not be able to make a lab when you wanted to this week, and we'll give you the first 2 passes on those. When you work in a group, there's no need to register your groups. However, you must submit all parts individually. Even if you worked on it in a group of 3 or 4 people, you must submit it yourself. So submit every portion yourself to get credit for it. We don't have a way to track groups. The lecture notes are all on Canvas files. Let's take a look. Let's take a break here. Let's go look at, just a second. I'm going to get my window ready here with my Chrome. Okay, I forgot to sign into Canvas on my Chrome browser. So let's just go take a look at what's on Canvas. Okay, now I'm going to share my screen again. Change my inputs. Okay, there you go. All right, so here's our homepage. Zoom in on that a little bit. So things over here. Syllabus is where we start. Announcement. Oh, schedule a topic. Super important. And that'll open in a new tab. Schedule of topics. We'll give you the link for the live stream every week. There, where it says playlist, Professor Darden recorded all of the material lectures, not the exams, not the intro, but all of the material lectures. He recorded them in pieces. So instead of like one video of an hour and 20 minutes, there's, let's say, 4 20-minute videos. And there's a playlist. Those are stored on Canvas, and you can go look at those. So if you miss lecture, you can watch the live stream later, or for things other than the intro and the exam reviews, you can go watch the playlist. This will show you when all of the projects are due, when you meet for lab, and this is a good thing to point out. Lab 6 is weird. Because of where Memorial Day fell, normally Memorial Day is in the, normally Memorial Day is in our lab week. But this year, because it fell, during our exam week, this year it falls on a Monday right before Lab 6. So Lab 6, if you want to go to Lab 6, you're going to have to go to Tuesday. And we know that there are going to be lots of people there, and we're going to have our staff double up on Tuesday. This is the best possible lab for having to cram everybody in, because Lab 6 doesn't have a quiz, it doesn't have an autograder, it just has the written problem and a survey. So it's the best lab for that. They're still going to talk about useful stuff in lab. They're still going to be talking about the stuff we're talking about in lecture, which is hashing stuff, which is super important for the Project 3. So do go to Lab 6, just it's going to be a little bit odd that week. Okay, so that's the schedule topics. Assignments is just when things are due. Autograder 1 and 2, and I've got that loaded up here already. This is what our autograder looks like. So this is, you don't see the debug and that stuff. You'd see a sort of limited view of it. Let me just do this. Back to project, okay. So you'll see something more like this, where you've got projects, labs, exams, and all. Exams, we're going to give you starter files on the autograder. You won't submit exams to the autograder, you'll submit them to Gradescope, but you'll download the starter files here. So that's why there's a tab called exams. Right now there's no exams. So the projects has got, right now, project 1 is up, project 0 is up, and you can see here, hey, I didn't quite get my project 0 completely working. I've got some wrong answers. Now on yours, you'll see on mine, those are links. You won't have links for those. But what you can do is look at, if you click on the timestamp, you can look at the feedback. Over here is a little download button. If you destroy your files, your computer glitches, whatever, if you've submitted to the autograder, you can always go download the submission. So if you look at the timestamp, it gives you a bunch of feedback. Here's the build output. So here's this make step running. So it built the project, and then scoring student executable. Case SN failed. Something went wrong. I got the wrong average somehow. So there's a hint here. The hint, we're just giving a hint based on most people who get this wrong, this is the problem. So it says if this is the only no size test you're failing, make sure you don't use EOF to control your read loop. Okay, don't use EOF to control your read loop. Important thing. So there's different test cases. This one, I had no output at all. In fact, my exit status was 1 when it should have been 0, etc. And then down at the bottom, how many test cases I passed, and my total scores at the bottom. So there's a lot of useful info in here. If you're failing all of the medium test cases, check that you handle the long form of -- mode correctly. So the hints are things that we've seen people get wrong, and we put in the most likely cause in there. So you'll submit, and if we go over to the lab page, there's lab 1. It's not public yet. We'll make that public like late tonight, early tomorrow for labs this week. So there's a lab portion you'll submit to the autograder. Okay, back to Canvas. So that's the autograders. There's 2 machines, identical hardware. If you come over to autograder 1 and you see up here, it says, it says the queue, it says there's 20 people in the queue. I'd check the other autograder. And if it's got a shorter queue, get on that one. We expect you to basically self-load balance the autograder 1 and 2. Calendar shows you the when things are happening. So we've got the Profis hours, labs are in there now. I started to get those in, populated. We haven't finished all of them, but we're working on it. And then my staff is going to be adding their own office hours also to the calendar, like today. Engineering honor code, files, really important. Bunch of things from lecture notes, projects, labs, practice exams. I still got to get those populated. Resources, you're going to hear me say this all semester. Canvas, files, resources, optimization tips. This document is all the things about doing things right, doing things wrong, how to optimize memory, how to optimize for time. So there's a section here on optimizing for time, speed optimization. There's also a section at the end, reading input, really important, read how to read input, and exam grade optimization. How do I optimize my exam grade? Read this now. Things that you can start doing to get ready for the exams now without doing a lot of extra work, just treating your process slightly differently, you will do better and be better prepared for the exam. So read this document. Okay, so that's files. Gitlab server, I'm not signed in, so you'll see the two most important ones, Makefile, you're going to use this for all of your projects, and Xcode redirect is important if you've got a Mac, and also Xcode redirect is useful for some other IDEs also. Okay, GitLab server grades. I can't show you that because that would show you everybody's grades and names and stuff like that. Gradescope, there's a link to Gradescope where you're going to submit lab stuff and exam stuff. Lab schedule is basically a spreadsheet with the links to the Zoom, etc. Media gallery is, if you go over to the media gallery, there will be this is how you can also get to the piecewise view. Oh, whoops, I guess it's a different place. So Professor Garden's got it linked in the syllabus, or in the schedule of topics. Office hours help, priority queue, Piazza, quiz tool, EECS 281 YouTube channel. So we got a link to the YouTube channel there. U of M course manager, I don't know if you get that. Alternate exam requests, so if our exams don't meet your times, let us know. Teaching evaluations, you'll do that later. And then that's most of the things on Canvas important to you. And if we look, where's my calendar? Well, on the schedule of topics, we've got days for the exams, and we're working on times. I've added 2 times to the calendar for each exam. So we're going to give it at our scheduled time, plus another time during the day to meet different time zones. So if we go to calendar here, if we move out 1, 2, 3 weeks. So here's right now what we're planning is, like basically class time we'll give the midterm, and then later in the day, 7 p.m. we'll give the midterm. And then for the final, that would be 1, 2, 3, 4 weeks after that. Midterm, our scheduled time by the registrar is 4 p.m. We're giving it then. We're also giving it at 9 in the morning is the plan. So those 2 times should cover most of the world pretty well, and you've got time to prepare. And like I said, there's the alternate exam request if neither of those works for you. Okay, let's go back. Where's my input? Okay, go back to there. All right, so that's a bunch of stuff. All right, lab groups. Okay, so projects. So projects is always individual work. It's always going to be submitted to the autograder. It's about 2 weeks for project. Well, that's a normal semester. During spring, we've got 1 week for project 1 and about 2 weeks for the other 3 projects. Yes, it's a rough schedule. We've been doing it this way, though, for this is 8th year. We've been doing 281 in the spring. And our statistics show that although we do have a slightly higher drop percentage than other semesters, the GPA of the people that stay with the class, the GPA is not statistically significantly different. It is statistics say it's basically in the same distribution of grades. So the first project is 1 week turnaround is pretty quick, and that's to get you used to this schedule in spring. We know it's a lot to do, but you've got you've got a lot of support and we've got a lot of things to do this semester. And we try to put a lot of effort into getting this well organized. And you'll see our schedule of 4 lectures a week. Is that the way I'd like to do it? No, I'd love to have more days off and do 2 lectures a day twice a week. But that's not good for you. It's too hard to absorb that much info in one day. I know, I've done it. So I had a class, like I said, met in the spring twice a day for lecture. We went to lecture, we had an hour off for lunch, we went to lecture, then we went to lab. And lab was 2 days a week, lecture was 5 days a week. And that 2 lectures a day is rough. So I know that. One thing I got to tell you, Professor Darden just had to sign off. He's not in the chat window anymore because he's doing his yearly review. And someone asked about the due dates. Okay, so Canvas has a tab called Assignments, which I didn't want to show you because there's a lot there. But the Assignments tab, all of those dates should be correct. So if you look in the Assignments tab, all the due dates in there should be correct. So you can use that to plan. So it usually, oh, I've got Nigel here with me today. Thank you, Nigel. Thanks for showing up. Yeah, Professor Darden's doing his yearly review right now. And then normally, whoever's not lecturing is going to be monitoring the chat. Thursday, I'm probably not going to be here, though, because my wife has a medical appointment. She's having trouble walking, so we got to get her to the doctor. Okay, so late submissions, you have late days. You have 2 late days. And you should use those wisely. I would not count on, oh yeah, I'll just use those late days for project 1, and then when I get sick, they'll help me. Maybe we'll say, hey, what about those late days we gave you? So use them when you need them. If you get really sick, we will help you out. But we want you to use the late days yourself and use them wisely. Now, the late days, you get 2 per semester. If you use them on project 0, I will refund them. And so that's nice just to know how the late days work. So you can use them on project 0 and then I'll refund them. And then if you need to use them on project 1, you'll know how to do it already. Now, one thing about using late days is you have to use enough late days to reach today. So let's say, for instance, today's Thursday and the project was due on Tuesday. Even though you didn't submit yesterday, you had yesterday to think and plan and code and debug yourself. So if you want to submit today, you would have to use 2 late days today. And you won't get your Wednesday submits back. Wednesday's already done. So you could have used 1 late day on Wednesday, submitted on Wednesday, used your full submits Wednesday, then you could use a late day on Thursday, submit on Thursday, get all your submits on Thursday. So waiting 2 days and then using 2 days is actually a waste of submits. Now the reason that you have to do that is we'll do a proof reducto ad absurdum, reduction to absurdity. Let's say it's the end of the semester and you say, well, I haven't submitted project 1 in like 6 weeks. I'm going to use 1 late day and submit project 1. And hey, I've had 6 weeks to work on it, but nope, can't do that. Okay, so the projects we're going to be using, it says here C++ 17. Really, our compiler is not completely 17 compliant. We're using GCC 6.2.0, which is completely C++ 11 compliant and some of 14. Just be careful. If it compiles on Cane with our makefile, you're fine, because Cane has the right version of the compiler, the same one that our autograder uses. There's a link on Canvas. So like when you go to, or sorry, not Canvas, the autograder. When you go to the autograder, there's either a submit button or there's a link that says click here to use late days. So it just goes through the autograder itself. You have to fill in a text box. So you'll click on the link, you'll fill in the text box, you'll hit the submit button, and that's basically just to make sure you don't do it accidentally. So like I said, beware if you're using another development environment. I code in Visual Studio. But there are things that Visual Studio won't even mention that won't compile on the autograder. So that's why I upload to Kane before I upload to the autograder, just to double check it. And you'll get used to these issues. You can also, even on Windows or on a Mac, you can open up a terminal, or on Windows, it's the WSL, we refer to it as. WSL, the Windows subsystem for Linux. You can get the compiler installed in there, run it with our makefile, and if it compiles in there, it'll probably compile on the autograder. So I do encourage you to use something like Visual Studio, but just make sure that it's going to compile when it gets to the autograder. So the autograder grades you not just on correctness, but also timing and memory usage. So you could get the right answer and still get less points or even 0 points. If you go way over on time and memory, you could lose all the points for that test case. Most of the test cases, you're going to get immediate feedback through the project cycle. We hold back some test cases for final grading, but most of them you get up front. And in fact, the Project 1 spec even says, it says somewhere either in the project spec or the Project 1 STLMU PDF, it says that the ones that we held out are just generated by the same program that generated most of the other tests. Like the ones that we wrote by hand that are tricky, we give you those up front. We don't save the tricky ones for the end. So you get approximately 3 submits per day for projects 1 to 3, 4 for project 4. You get more submits per day in the spring, and you can earn an extra submit per day by doing stuff on the autograder, by finding bugs. So, how do you find bugs? What you do is you submit test files. I can't remember if there's a slide for that or not. Okay, so the way you find bugs is you submit test files. And these are input files. These are input files. These are not code. So this is an input file that the program would accept. What we did was we took our working solution and we added bad code to it. And we created one bug for each thing that we thought maybe you might do wrong. Like, ooh, what if someone forgot to do this? What if someone forgot to do this test? What if they did less than or equal to instead of less than? Stuff like that. Submit test files early. So not only do you earn an extra submit per day from that day to the end of the project cycle, you earn points for it. But that's not the real reason. The real reason to submit test files early is that if your own program gets the different output from ours, the first one like that we see, we will show you in your feedback, here's our correct output, here's your output. And now you've got something perfect to debug. We've given you what's called an oracle. The oracle always gives the right answer. So in the real world, you don't have an oracle. What do you do in the real world? You write input, you go through it by hand, and you predict the correct output, and then you make sure your program does it. We're helping you. We're giving you a shortcut here. If you give us a test file, we'll tell you if you get it wrong. And if you give us 10 test files, the first one that we grade that you get wrong will tell you the right output for the first one of those that we encounter. So submit test files early. I've seen people, students, who are like, oh, Dr. Paley, the project's due today, and I've been working for 4 days. I've got one test case that's over time, and I look at it, and they're losing like 0.12 points because they're a little bit over time on one test case. And they've been working on that for 4 days. And I say, what about the 10 points for the test files? I'm going to do that later. You've been working for 4 days on 0.12 points, and you've got 10 points that have been sitting there waiting for 2 weeks for you to grab them that you haven't even started yet. You will probably not get all the bugs on your first submission. It will probably take you multiple submissions and multiple test files to find all of the bugs. And that's a process that you have to go through to make good test files. And if you make good test files that find our bugs, hopefully they will help you find your bugs. So now before you ask us for help debugging your code, what you should be doing is submitting to the autograder. You should be including your own test files. You should have tested everything that we've given you. You should have run it with Valgrind. I have students every semester who say, no, my program works perfectly. The autograder just doesn't like me. I run it with Valgrind with the spec test that's, the little 4x4 that's in the spec. Run it with Valgrind. 10 pages of errors go flying by of uninitialized variables, stepping out of the bounds of memory. So make sure that if your program isn't giving right output, or wait a minute, even if it is giving right output, run it with Valgrind. I had one of my staff submitted a solution to our final exam problem. I ran it and I got wrong output, different from his. Ran it with Valgrind. He had one little tiny error in it, and we fixed that and his solution worked perfectly. But he never ran it with Valgrind. He got the answers that he expected and called it done. Ran it on the Gradescope, wrong answers. So always use Valgrind, even if you think your code is working. Here's another example of the autograder. That one thing I didn't have on my submission was I didn't have any of the blue ones. Blue means it's over time or over memory. And if it's blue, then click on the timestamp, go search for this test case name. Oops, I overwrote it. Go search for that test case name in that file, or open up that file. You can, when you open up the file, do a search, Control F, and search for the words hint and the word exceeded. Those two words will find you a lot of the things that are wrong. Not everything. I started to say everything. They'll find a lot of things that are wrong. It'll tell you what you did wrong. It'll give you, sometimes there will be hints that'll help you with those. And also the test case names. Every project has a legend that tells you what the test case names mean. Project Zero has a legend, tells you what the test case names mean. So if you're getting a test case wrong or over time or over memory, look at what the name says, what it tells you about that test, what it's doing, what it's testing, and see if that helps you. And if it doesn't, sure, come to office hours, ask us questions about it. We'll be happy to help. But if you do it yourself first, you're going to get better at it, and you're going to save yourself time by answering it yourself. There's a lab stuff on Valgrind. We'll do it. Let's do it. Let's do a 1-minute Valgrind help. I need a slide with a little bit of blank space on it. Okay, we'll use this one after it's done. Okay, we'll actually, I'll just write on this graph and I'll clear it. So how do you use Valgrind? Really easy. Make debug. Okay, and then I'll do Valgrind / and let's say this was project 1. It would be puzzle, LE, puzzle _ debug, and then your normal command line. And so like I might do -q > spec.txt. And then watch the Valgrind output for errors. So that's the quick 1-minute introduction to Valgrind. So our make file knows how to, when you make debug, it makes a debug executable. When you run the debug executable with Valgrind, it has line numbers, and it'll tell you, at line 157 you used an uninitialized variable. At line 203 you stepped outside the bounds of memory. Now Valgrind is not quite that readable, because it turns out the people that are capable of writing a program like Valgrind not so good at communicating with human beings, but you'll learn to read it from using it. Or come to office hours. Say, hey, here's my Valgrind output. What does it mean? We'll be happy to answer it. Okay, what this slide that I just wrote over the top of is about is, granted, this is fall of 2013, the first year I was at U of M, but I could reproduce this chart for every semester. It's almost the same. What this is, the x-axis is when someone first submitted. So the autograder was open from like the 20th through the 30th. 10 days to submit to the autograder. The vertical axis is their final score. So this doesn't mean the people that submitted here got 100 on the first day. It means the people whose first submission was the first day, most of them eventually got a score in the like 95 to 100 range. Most of them got 100. There's like a 98 and a 95. But everyone else who submitted that very first day got 100. There's one oddity here. I'm guessing if I look back at the data, I bet that person dropped. But everybody else who submitted early, and look at this, it's almost like a hyperbolic curve. The later you wait for your first submit, the bigger the range of scores. So people that waited until, like, look at this. This is like the last hour of the last day. They may as well have rolled some dice to get their score. And there were no hundreds in the last couple hours. People whose first submission was the day it was due did not do as well as the people whose first submission was even 3 days earlier. Look at the people that submitted 3 days earlier up here, 2, 3, 4 days earlier. Look at those. There's a lot of 90s to 100s in there. So take advantage of the autograder. When I do this in person and I show this graph, I don't get to hear it now. I hear students laughing when I show you this graph, but I can repeat this every semester. There's going to be people who do this. If you think, when I was in 280, I just started the projects the day before they're due, no problem, I can do that again. Maybe. Out of, what have we got, like 280 students, there's maybe one of you who can do that. Usually there's 0 of you who can do that. These projects take time to work on, to understand, to debug, to optimize, to get them to the point where you're happy with them. So we want you to use that time. If you are not submitting to the autograder, you're not taking advantage of it. Though you don't get to save up those, 6 submissions a day until the end and submit, 42 times on the last day. You get 6 submissions per day, 7 if you earn an extra one by finding bugs with your test files. So get the submits in early. Okay, exams. So both exams are, I missed the dates here. Okay, so this was 5/26, I think, and 6/25, something like that. I believe those are right. I forgot to update the dates on every slide. This is why I hate dates in slides. So yeah, so they're later than that. They were correct earlier in the slides, and let me see. I've got one of them up. So that's so that's 6/25 is right, and 5/26 is right. Yep, sorry about that. I missed those on the second version. Okay, so there's going to be a multiple choice section and written coding section. Notify us ahead of time if you've got a conflict. We've got the times are already in the calendar when we're going to give the exam. There's 2 time slots. You don't have to tell us that I'm going to take this time or that time. As long as one of those times works for you, you're good. Take either one of them. We don't care. But if you can't make either one of those, tell us ahead of time. Also, this reminds me, if you have an SSD form, don't email us. So if you've got an SSD form, go to the Canvas, the alternate exam request link, and it'll give you a place to attach your PDF for your SSD, and we'll get you the whatever accommodations you need in there. So if you've got those, please do those now. Don't wait until an hour before the exam to do that. Okay, now curving. If necessary, we will change the points required to pass the exam. So remember, 50% is passing. So if you get 50%, you are guaranteed to pass. If the exam was too easy, we don't raise the bar because that's our fault. If the exam was too hard, we lower the bar because that was our fault. We try to take responsibility. I feel if I goof something up, it's my responsibility to make it right for you. So when I was a student, freshman year, Chem 1 lab, I got, I think, a 93% in Chem Lab, and I got a C. Because my lab instructor had never taught it before. He was really sort of lackadaisical about grading, like, I think you got it, sure, I'll give you the points. Oh, I don't think you quite got the pre-lab, I'll take a point away. And then we got to the end of the semester, and the instructor told him, no, fit everybody to a bell curve. And so I knew someone getting like an 85 who didn't pass Chem Lab. 93 got me a C. So that was ridiculous. I've learned from bad instructors what not to do. So if the exams are too easy, that's our fault. We don't raise the bar. If the exams are too hard, that's our fault. We lower the bar. Also, we may also adjust grades upward. So if just changing the bar for passing is not sufficient, we might lower the bar to get an A or lower the bar to get a B. We'll never raise the bar, but we might lower it. And we'll also send out mid-semester, we will send out a grade estimate. Like after we've got the midterm graded, we will send out a grade estimate of like, if the class was ending now, this is where you'd be. And if it isn't a C, this is what you need to do to reach a C. Okay, will solutions be posted? Yes, for labs. Look on Canvas afterward, after they're due. For in-class exercises, no or yes. Some yes, some no. For projects, no, never. For exams, no. Midterm solutions, we might go over, like after the exam, we might go over like the elements of what was needed in a solution, but we don't generally just give you the right code for them. But we're going to give you practice exams from previous semesters. I just got to get those ready on Canvas. I got to remember to add that to my to-do list. Lectures. So you can print out or use the digital version of the lecture notes. You've got basically just about, I think the first half is posted up until, but not including the midterm review. So I've got to get those updated because our lecture numbers shifted slightly because of where the Memorial Day fell and spring and stuff like that. So I've just got to get those updated and they'll be visible. So you can print them out, write on them, taking notes during lecture by hand. And I don't care if it's a tablet or on paper, but writing by hand makes better long-term memory connections than typing. Proven in study after study. Writing things by hand makes better long-term memory. So that would help you. I would look at the notes beforehand, read through the printed lecture notes before lecture to know what we're going to be covering. You don't have to understand every line of code on every slide, but you should do more than say, oh, complexity. Okay, I'm all set for tomorrow. Or actually, tomorrow would be stacks and queues and priority queues. So look through the slides, know what you do understand, know what you don't understand when you come to lecture so that you can get questions answered. Here it's time for my take on questions. So other professors might tell you there's no such thing as a stupid question. I feel very differently. I feel there is a whole category of stupid questions. And those are the questions that you never got an answer to because you never asked them. It's never stupid to ask a question. I think it's stupid to not ask it. Because when you have a question, it's because you've identified a place in your knowledge construct that has a hole in it. And when you fill in that hole, maybe two things that seemed like they were completely unrelated, you now see the big picture of how things hook together. And that's really important to reach that point. So make sure that you are asking questions, whether you type them in the chat, whether you come to Profis Hours, whether you post them on Piazza anonymously. Get them answered. Get those questions answered. Now, not everything that we do in lecture will be in the slides. Someone might ask on the chat, say, hey, can you do another example of that? I'll be like, yeah, okay, let's add a new blank slide and let's type a new example in there and let's do that together. So, whoops, I accidentally changed slides here. Where was I? There we go. Sorry. So not everything that we talk about will be in the slides. I might do things on the tablet that aren't in the slides. I might expand upon what's in the slides, but it will make it into the video. If you can't come to lecture every day, still watch the videos. Watch them soon. Do not wait until just before the exam to start reading the lecture slides and watching the videos. You might look back at them to refresh your knowledge of a certain section of a certain lecture, but you shouldn't be waiting until right before the exam to get ready for the exam. Getting ready for exams is a process. It's not an event. So have a good process along the way. Now, you don't want to just pass. You want to succeed. You want to do well in here. What do you need to do? Well, be serious about this class. This class is ranked by students as a heavy workload. It does deserve it, but it's also, you're going to get a lot out of this class. What you put into it is what you're going to get out of it. If you put a lot of effort in, you're going to get a lot out of it. Allocate sufficient time. I can't tell you the number of hours that's sufficient for you, but it's going to be more than 203 or 280, and then double that because we're in the spring and it's double paced. Be proactive. Don't wait until the last minute. Don't wait until the next day to do things. Like if you're stuck, your code won't compile. Okay, you're probably going to have to come to office hours for that, but you can do other things. You can get ready for lab. You can get ready for lecture tomorrow. You can create some more test files. There's lots of things you can do even when you're stuck that will still help you make progress. So do ask for help soon, sooner rather than later. Practice writing code by hand. So preparing for the exams when you're going to have to write code, you can treat labs and projects, etc., as exam questions. Say, hey, I've got this function I know I have to write for my project. I'm going to give myself like 40 minutes, and I'm going to spend 10 minutes of it planning and writing out on paper how it's going to work, and then 30 minutes of coding, and then take that, type it in. Does it compile? If not, what did you do wrong? Does it work? Test it. Get it working. When it's working, compare your final version to your original version. Other than the syntax errors that prevented it from compiling, what logical errors did you make? Did you miss an edge case? Did you goof up an if statement? So you're not doing that much extra work, but you're learning more from it to get you more prepared for the exams. Okay, Computing Cares. I'm going to have to switch over to Chrome for just a second. We've got Computing Cares as a group at U of M, and they created a video, which we're going to show you here. Okay, so I can change my input and my audio.
No, it does not deserve its reputation at all. I think it gets a bad rap because people are complaining about it when they're taking it, but when you're actually looking back on it, I don't think it was nearly as bad as, at least I didn't think it was as bad as people made it sound, or as I thought it was when I was doing it in the moment.
So I guess it's a weeder in that if you have bad habits, you'll get bad scores. But all of my friends who all enjoy the course and study, we do fine.
I feel like it does have that weeder aspect to it, but I don't think people should take it as seriously as everybody says it is.
Debugging, for sure, but that's always the most frustrating part and the most rewarding. One time I had a makefile that would not compile because I used spaces instead of tabs when I copied it over. It took me a whole week to fix.
I wasn't ready for the time commitment with the projects, and I also wasn't ready to ask for help from other people. With project 1, I pretty much decided that I was just going to figure this out by myself, and after a couple of those 10-hour sessions in Hatcher, I realized that wasn't going to happen. So I would say be comfortable with talking to other instructors or things like that, because that's where I've learned the most. Is not by, a lot of the concepts in this class are pretty hard. It's fine to ask for help from someone else. So.
didn't do so well in the midterm. And then what happened eventually was that when we moved to new content, I really started to get it, and I was able really to understand it, which was really nice. And even though I didn't know it for the midterm, I knew it for the final.
Get something correct that I've been working on for a while. I think it's just very exhilarating to like type in, like, go on diffchecker.com or whatever and put in the two outputs, and then it's like the two files are identical. It's very exhilarating.
One time I wrote code. It was like a pretty considerable amount of code, and it compiled on the first try. I mean, it didn't work. It didn't run correctly, but it compiled.
Oh my gosh. It was usually midnight. So I still lived in the dorms when I took 281, so there wasn't really much to go celebrate. But since Pizza House is open really late, I usually got feta bread.
I usually get a bag of Flamin' Hot Cheetos and just chill out with some Netflix.
The best meal is probably the Pizza House late night Cravers deal, because you get cheesy bread or like a personal pizza, whatever you want, plus a milkshake of any flavor. That's super good.
No.
No.
I had to devote a lot of time to this class, more than really any other class that I had this semester. But at the same time, I know I'll use the tools and things that I've learned in this class throughout the rest of my technical career.
I actually really enjoyed this class. So just like, I think a lot of people kind of dread this course in a lot of ways, but like you can learn a lot from this. And I think if you just tackle it with the right attitude of just wanting to go to class like every day and learn, it's actually like really fun and you learn a lot. So.
I think I'm definitely happier now that it's been like a little while, because I think I've been able to use the stuff that I learned in that class and apply it into other classes, and kind of getting the chance to like create your own data structures and go about the process of starting a project from like start to finish in really like your own creative way. I think just really translated well into what I needed to do for other classes, especially upper levels in EECS. And so I think being able to apply it later on, I look back on it and I'm like really glad that that's what I got to do.
I feel like now that I've taken 281, I really know what computer science is. I feel like beforehand I didn't really know what was expected of me, and now I do.
Start earlier on the projects.
Just start the projects like right when they're assigned.
And go to office hours. Definitely go to office hours.
To not be afraid to ask questions.
Writing variables that make sense, and especially like writing functions so that when you analyze your code later, you can tell which parts are slowing down and which parts are fine.
And go to lecture. Watch the lectures, at least that pertain to the things on the project.
Starting early has a lot of benefits, especially when you go to office hours. I know I've gone to office hours sometimes. I've been there for 3 hours. I move up like 2 spots, and it's frustrating. But if I start early, I only have to wait like 5 minutes.
I know everybody says start the projects early, but when they say start the projects early, they don't mean start coding day one. They mean like read the spec, figure out kind of like how you want to set up your classes and how you want to set up all of your code. That doesn't necessarily mean you need to start coding right away, but I feel like start the project early means have a sense of what you're going to be doing for the next 4 weeks.
Okay, I'm back. So that was made by the Computing Cares group without any input from the 281 staff. They just found a bunch of students who volunteered to be in the video. And I think it's funny. Are you going to miss it? No. But I got a lot out of it. With the advice of starting the projects early, we did a little bit of data running. The first semester we showed this video, I looked at how many people had submitted the project in the first X number of days of that semester compared to the previous semester. And I did a fall and a winter just to make sure, spring isn't quite fair. But I looked at how many people, what percentage of the students submitted in the first X number of days of the project cycle, and it went up by 10% when we started showing that video. So I guess that goes to show that even students who don't believe their professors will at least believe their fellow students. Okay, so how many hours per week do I need to spend on 281? Well, it varies widely depending on how good you are at coding, how good you are at theory, how well you plan and execute your process. The important thing, like the student said, is start planning. A good example I had about 2 years ago. Student who during project 3 broke his hand in a door, his right hand, and he's right-handed. And so we gave him a couple extra days for project 3. He got it done, he got it working. Then when project 4 came, I asked him, do you need extra time? Or, we don't want to give you too much extra time because then you're going to run into the final. And he said, no, I don't need any extra time. He said, on project 3, I did so much time planning, so much more time planning than I ever did before. I not only spent way less time coding, I spent less time overall. So that's what he learned from having a broken hand, taught him that, was do more planning before you start coding and you'll spend less time overall. If you start jumping into code the first thing you do, you don't have a good sense of where to go yet. The other thing is be willing to throw away code if you have to. Professor Noble had to do that. He taught with us in the winter, and he wrote one of the projects, and he thought he had a good idea of how to do it, and he had to throw out like 2 complete functions and redo them. Okay, study groups, generally a good idea for the lecture material, for getting ready for the exam. You are welcome to talk to people about the projects, about how to organize it, about what has to be accomplished. But when you start looking at other students' code, you can't unsee it. And so that's going to lead to problems. But talking to other students about what has to be done, and I've had students in office hours say, like I have a student who says, I'm getting like these 3 test cases wrong, and I just don't know what it is. I say, okay, let me look that up. And another student will chime in and say, oh, I just had those wrong yesterday, and I figured out that I wasn't doing X. Nothing about how they did it. They just said, I forgot to check X. And 15 minutes later, the other students was working. So not only is mentioning things to other students helpful, it can help you if you say, well, remember that when you do this, you have to do this, this, and this. If you can just say those 3 steps and formalize your understanding of it by saying 2 sentences to another student, you'll understand it better yourself. Useful tools. So Make, you have to use Make. We give you a Make file. It's linked in the Gitlab link. It's linked in under Canvas, Files, Projects. Right at the top there's a link to our Make file on our Gitlab server. So use our Make file. Be careful, like one of the students mentioned, if your editor changes tabs into spaces, that's bad. So don't use an editor that changes tabs into spaces. Make files are old technology and they're required to have tabs in them. So knowing how to use an editor like Vim or Emacs, where you can be on cane using an editor, is a good thing. You'll say, well, who needs editors like that? I can always GUI in. Well, maybe at some point you'll have to have a job where the web server is down and you have to go modify the web server config file before you restart it. You've got to use the editor without a web server working. Using some type of version control system like Git is good. We use Git for some of the things that we give you. Also, make sure you make a copy of your code. Do not have one copy of your code and hope that nothing goes wrong. So you should be doing at least one of the first 3 things that we've already mentioned. Uploading to the Autograder, uploading to Cane to test compiling with G++, uploading to a GitLab server. private repository, obviously. Or, one thing we haven't mentioned yet, copying your files to a flash drive. If you do none of those things and your computer dies, then you look like someone when MSU just beat U of M by 1 point with a touchdown with no time left after a flub kick or a punt, I think. And the funny thing is that guy was in 281 the semester before this video happened. So we get students every semester who say, my computer died. My only copy of the code is on there. Well, it's due tomorrow and you haven't submitted to the autograder yet. Oh yeah, but my code was working perfectly. I didn't need to submit to the autograder. I'm totally done if only I could get to my code. So make a copy of your code. Do not have only one copy of something that's this important to you. So using an IDE is good. IDE stands for Integrated Development Environment. So IDEs are things like Xcode and Visual Studio. VS Code is not an IDE. VS Code is a shell with an editor with links to other tools, but I would not call Visual Studio Code a real IDE. I would really encourage you, even if you're used to using VS Code, use Visual Studio or use Xcode as appropriate to your OS. If you're only using Unix, well, then you're kind of out of luck. You can't use Xcode or Visual Studio inside of Unix. But an IDE has all of these things together. A text editor, advanced code browsing where you can look up function definitions, you can jump directly, like if you've got a line that says call function X, you can jump to the code that implements X. When you mouse over a function name, it'll tell you what parameters it expects, etc. Some sort of project management, make, build sort of step. Interactive debugger is critical in 281. If you've never used an interactive debugger before, you're missing out. If you're not using an interactive debugger, you're saying, no, I'm good with the 30-year-old technology that Dr. P used when he was an undergrad. If you're spending all your time adding C-error statements to send debugging output and then commenting them out, commenting them back in, you're wasting time because you're not using an interactive debugger. So here's, like I said, a partial list of IDEs. So Visual Studio 2000, I would say 2017 or 2019. And also make sure you've got the latest version. Make sure it's patched under Windows, because the latest version does something good with Unix input files that Visual Studio didn't used to do. Xcode, free for a Mac. NetBeans, Eclipse, Visual Studio Code are all free, but you need a separate compiler for them. You need to download a compiler separately. Plotting tools, good to learn to use a plotting tool. GNU Plot, Excel, MATLAB, or obviously Google Sheets. So if you can do Excel, you can do Google Sheets, and you've always got it with you wherever you have a web browser. So before the midterm, things we're going to be talking about are complexity analysis, building blocks of elementary data structures and algorithms. Things like stacks, queues, and priority queues, plus others. Vectors, vectors, decks, etc. How to implement things. Time measurement and optimization. How to do algorithmic problem solving. How to pick the best algorithm. Then once we get to the midterm, and after that, we're going to look at more sophisticated algorithms and data structures. Things like binary search trees, not just binary search trees, but self-balancing binary search trees that will never become a big stick no matter what order you insert things in them. Hash tables. Hash tables give us O of 1 average case insert search remove. So hash tables, really important. Lots of things that we teach you in 281, like in Project 1, the Project 1 STLNU suggests use a deck. Don't use a stack, don't use a queue, use a deck to do both of their jobs. So then you'll think, oh wow, deck is really awesome, I'm going to use that for everything. Then you get to Project 2, And in project 2, you're going to use priority queues. And you'll be like, oh my gosh, priority queues are so cool. I don't know how I lived without them. And then you'll get to project 3 and you'll be like, oh, hash tables. Hash tables are the solution to everything. And that's almost right. They're solution to a lot of things. So we show you a lot of new data structures that are all way cooler than anything you did before. And then for project 4, we're going to be looking at graph algorithms, algorithm types, and different algorithm families, very complex projects. So in project 4, you're going to have really simple data structures, but really time complex. So data structures and abstract data types, when we need a way to store information, we need some place to store it, and abstract data types provide an interface of how we can do things. The data structure is an implementation of that. So we might talk about a container. Well, what is a container? A container could be a vector, a linked list, a stack, a queue, a deck, a priority queue. There's lots of different containers. How do they organize the information? What do they do with the information? So when we look at algorithms, an algorithm is a well-defined procedure that solves some sort of computational problem. An algorithm transforms input data into desired output. In fact, that's what every useful program does. And by useful, I mean things beyond Hello World. Every program transforms information from one form to another. Every part of our program should be doing that also. Every part of our program, like when I break it down into functions, like project 1, I could have a function that processes the command line and gets me the important stuff out of the command line. I could have another function that reads the input file and gets it into a data structure in memory. Those are all transforming information from one form to another. I could have a function that does the searching part of project 1. It takes the data that the reading input produced and it goes through the searching and gives me the data that I can use to then, in maybe another function, produce the output. So we're always transforming information from one form to another. Algorithms are tools. We like to talk about algorithms because if you understand the algorithm, like let's say bubble sort, if you know how bubble sort works, you can rewrite the code to work in a different language, work with a different data structure. Like I know how bubble sort works. But if all I have is a copy of bubble sort code and it works on an array, how do I get it to work with a vector? How do I get it to work with a linked list? Can I bubble sort a linked list? Sure, you can. How would you do it? But if you know the algorithm, you can move on to an implementation with a different language, a different data structure. Okay, so when we want to design an algorithm and a data structure, what we care about is how long does a given operation take? How many times am I going to do that operation? How much space does this data structure use? And some of this we can do before we write the code. We can't get every detail perfect before we write code, but we can do some planning and avoid the obvious wrong choices and make some good choices. And hopefully avoid wasting time on a bad design and concentrate on a design that's either very good, perfect, or close to it, that will require minimum changes. When I first taught 281 back in fall of 13, I implemented the first project. The autograder was like available to the staff, but not the students yet. I submitted to the autograder and so I was like over memory. Like, I'm not over memory, I'm the professor, and oh wow, that was dumb. Yeah, that was wasteful. I looked back at my data structure and realized I was saving stuff I didn't need to save. And I was like, oh my gosh, it's like 1:30 in the morning, but I'm not going to go to bed until I can get 100 on this project. So it took me about an hour and a half, 2 hours to change my data structure a little bit and then find the places in the code that affected, and then I was fine. But, even your instructors aren't perfect. Sometimes we have to redo our data structure, redo the code that accesses it. So when we're designing our application, is it better to use algorithm A or B? Is it better to use data structure X or Y? They may be related choices. If I choose a better data structure, my algorithm can be better. Like I mentioned in the Project 1 tutorial video. Oh, you didn't know there was a Project 1 tutorial video? It's in the first section of the hints. There's a link to a video on YouTube that's got a bunch of help for Project 1. So I mentioned one thing in there is things you don't want to do is lots of linear searches. So we can, if we get the right data structure, the algorithm can be more efficient. And for a given piece of code, where is the bottleneck? Where is the place that's hard to get information into or out of the bottle? It's the neck of the bottle, the narrowest part. Where in your code is the narrowest part that's slowing it down? And how do you speed it up? And that's, like I said, Canvas, files, resources, optimization tips document will help a lot with that. Okay, we're just about out of time here. We got a little exercise. I want you to think about this one. Tomorrow we're going to come back and look at the solution. So if, and let's just do a little, what this is doing is, I've got an input. Let's say my input was 3, 1, 2. My output, what I want in the output is 2, which is 2 is the product of everything except this index. So this is like index 0. So index 0 should be the product of everything except index 0. Index 1 should be the product of everything except index 1. Index 2 should be the product of everything except index 2. So, can you write something to do this? Can you write 2 versions? Could you write an n squared version? Could you write an O of n version? Would the O of n version have any bugs in it? Would there be things that you might have to fix that a simple, straightforward O of n might have overlooked? So think about those, and we'll talk about solutions tomorrow. Last 2 slides here. So developing your skills at problem solving, analyzing algorithms, developing software by writing code, and this is a process of practice and repetition and rewriting that you have to go through to get better at coding. If you want to get better at swimming, you don't just read a book about it. You jump in the pool every day. And so you've got your pool with you. You got your laptop, tablet, whatever you're working on, you should be coding every day. Memorization, and I don't mean necessarily rote memorization. What I mean is know your own code. I ask students all the time in office hours, okay, what's your data structure? What's in your data structure? Let me go look at it. No, just tell me. You've got a vector of what? I don't remember. Well, if you know the data structure, you know, oh, I've got a structure that's got X, Y, and Z in it, and that's what goes in this data structure. Great. Knowing your own data structures is going to save you time in the long run. When is a given technique appropriate? Pointers. Project 1. Don't use pointers on Project 1. You don't want pointers. They're going to lead to bad other choices. What can I do if I don't have a pointer? Watch my video. My video makes it really clear, and I talk about it in the video, in the Project 1 video. Good code versus bad code. Good code is all of these things. Good code is modular. It's not a 1,000-line main. It is both concise and readable, which are sort of at odds with each other. Concise meaning short, readable meaning I can understand it. So we don't want to make it too long, but if I notice, hey, I'm writing this code that I wrote already once before, let's make a function out of it. Now my code has gotten more modular, it's gotten more concise, and it's gotten more readable, and it's gotten more debuggable. If that code turns out it has a bug in it, I fix it in one place instead of 3 places. Functional robustness. I should know what's coming into this function. Is it already been checked for validity, or is it my responsibility to check that the input is valid? Code reuse I just mentioned, and we want to write our code to minimize bugs. Okay, that's it for today. I'm going to finish up the stream here and get some lunch, and I'll see people at Prof's Hours at 12:30.